All right, so in the last video we learned about the inner product, but we would probably like to extend our definition of matrix multiplication beyond just row matrices and column matrices. So, but the key is the inner product, because what happens when you multiply two matrices is that each element of the product is an inner product of the ith row and the jth column. So if you have a uh, two matrices and you multiply them, and let's say that C is equal to the product of matrix A times matrix B, then the elements Cij, so that's the element in the ith row jth column of this matrix C, is equal to the product, the inner product of row I of matrix A. Okay, I'll just put that like that. That's our row matrix, right? And times the column, let me write it like this, column J of matrix B. Okay? All right. Now, I know that that's a little confusing. So let's just let's go on to example 2, and hopefully it'll make more sense. All right, so we're going to multiply these two matrices. Now notice that the number of rows in matrix, the number of columns in matrix A is equal to the number of rows in matrix B, so we can multiply them. So what we're going to do, we're going to compute the product A times B, and each element in this product is going to be the inner product of the ith row and jth column. All right, so let's take a look at the first row. So let's just work with the first row. Actually, I think what I'm going to do, I'll use a highlighter. All right, so the first thing I'm going to do, I'm just going to multiply this row times this column. All right, I'm just going to multiply it using the inner product. So what do I get when I do that? I get 3 times 1 plus 1 times 4 plus 4 times 2, right? So you can see the 3, 1, 4 from this first row, and you can see the 1, 4, 2 from this column, okay? And that sum is going to be the first element of this product, the element in row 1, column 1. Okay? So now let's go on. Let's do the first row, second column. So now I'm going to take the first row times the second column, and that's going to be the element in the first row, second column of my product matrix. All right? So I'm going to take 3 times 3 plus 1 times a negative 1, and then I'm going to add a 4 times a 4. Okay, so again, you can see the 3, 1, 4 from the row, the first row, and then you can see the 3, negative 1, 4 from the second column, and that's the element in this first row, second column. Okay? All right, let's keep going. It's kind of a process. So now I'm going to do first row, third column. I'm going to come up with the element in the first row, third column of my product. So what am I going to get? I'm going to take 3 times a negative 3 plus 1 times the 2, right? And then 4 times 1. Okay, so now I've got my first row complete of my product. So we need to move on now to the second row. So I'm going to highlight the second row and the first column, and I'm going to just come up with the inner product of that second row, and the first column, and that will be the element in the second row, first column of my product. All right, so we're just going to take negative 1 times 1 plus 2 times 4 plus 3 times 2. All right. Again, we got -1, 2, 3 from the second row of matrix A. And then we've got the 1, 4, 2, 1, 4, 2 from the first column of matrix B. All right, so now let's move on to the next column, right? So I'm going to do the second row, first column. All right, so we have -1 times 3 plus 2 times -1 plus 3 times 4. Okay, -1, 2, and 3 are from the second row of matrix A, and the 3, -1, 4 are from the second column of matrix B, and that creates our second row, second column element of the product. All right, we just have one more element, or one more element in the product to compute, and that's going to be the second row, third column element. So I'm going to multiply the second row times the third column. Okay, so I'll highlight the third column now. All right, so let's just go one by one. It's kind of a tedious process. So -1 times -3, and then plus 2 times a -3. Oops, not -3. Next element is 2. And then plus 3 times 1. Okay, so you get the -1, 2, 3, -1, 2, 3 from the second row of matrix A, and then you have -3, 2, 1 from the third column of matrix B. All right, now it's all arithmetic. So what did I get when I add these all up? So I'm just gonna do all this arithmetic now, and what I end up with is 15, 24 minus 3, 13, 7, and 10. All right, so the product of these two matrices is this new matrix. It's a 2 by 3 matrix, 2 rows, 3 columns. And you might notice that this was a 2 by 3. This was a 3 by 3. And you can see it creates a 2 by 3 matrix. So when these two numbers have to match, the number of columns in the first matrix has to match the number of rows in the second matrix. And what you end up with is a 2 by 3 matrix. So if you want to know what the dimensions are of the product, it's these outer numbers. Okay. Now, you might also notice that another thing to point out is that matrix multiplication is not commutative like normal numbers are. So, if you have like 2 times 5, that's really the same as 5 times 2. That's the commutative property of real numbers. Multiplication is commutative with real numbers, but it is not commutative with matrices. So that's an important thing. You see, if I switch these two matrices around, we couldn't even really come up with a product, right? Because if I switch these two matrices around and I want to compute, say, B times A, then I'm taking a 3 by 3 matrix times a 2 by 3 matrix, and these numbers don't match. So this would be undefined. We cannot come up with that product because we don't, there's not enough, we wouldn't have this one-to-one match between the columns in matrix A and the rows in matrix B. So it wouldn't work. We cannot multiply B times A, but we can multiply A times B, like we just did. All right. Now this just takes some practice. It's a little bit tedious of a process, but just take some practice, and you'll get good at it. So I'll meet you in the next video for some more practice. In fact, you might even look ahead at the next problem and try it. But I'll meet you there.